Karibu Ibra Network Lab. Hii ni kozi kamili ya Cisco Certified Network Associate. Kupitia kozi hii utajifunza jinsi gani na namna network inavyofanya kazi. Okay, before we get started, I would like to say thanks to Jeremy's IT Lab. I use Jeremy's IT Lab to prepare myself for my CCNA exam. I highly recommend you also to use Jeremy's IT Lab as an extra supplementary material to prepare yourself for your CCNA exam. Okay, in this lecture video, we are going to have a discussion about Internet Protocol version 4 header or IP version 4 header. I used Google Gemini to create this image, so thanks to Google Gemini. You can use different sources of the internet to find the image of IP version 4 header. And also in this lecture video, I'm not going to spend a couple of time to explain the source and the destination IP address, because I have already made the video that I used to explain the source and the destination IP address. However, we are going to cover these different fields. As you can see from this image, we are going to cover them in depth. And I don't think if you really need to memorize the clear arrangement of this IP version 4 for your CCNA exam, but my heavy recommendation is you're supposed to know each field and its function. And let's get started. The first field of IP version 4 header is the version. This it is 4 bits long and it is used to represent which version it is used in the internet protocol. So for example, there are two versions that are used, that are commonly used in today's world. So for example, whenever you see in the version field, it is going to be represented by IP version 4, and this is a binary bit which is 0100. And also you may find IP version 4 which is represented by binary bits ambazo ni 0110 or this number 6. However, whenever you see if it is going to be used these 6 together with these binary bits, the entire header it is going to be changed, because this IP version 4 header it is quite different from IP version 4 header. The next field is internet header length, IHL. It is also 4 bits long. It is used to indicate the total length of IP header. Now, this it is very important part that you're supposed to know in IP version 4 header. It identifies the length of the header in 4 bytes increment. Now, for example, if the value in IHL it was 5. Now, since tumesema kwamba IHL inakuwa identified by 4 bytes increment. So, for example, as we said, kama the value katika IHL ingekuwa ni 5, so we are going to take 5, we're going to times by 4, which is going to identify the length of this header. So we are going to take that value from the IHL field, then we times 4, which is incremental by 4 bytes. So 5 times 4 we are going to get equals to 20 bytes. Now, by the way, the minimum value from this IHL field is 5, and the maximum value from this IHL field is 15. Now, whenever it is putting any value here, we are going to times by 4 bytes incremental. So the maximum value it was 15, then 15 times 4 equals to 20 bytes. Now, by saying so, the minimum bytes from IHL field is equal to 20, and the maximum bytes from IHL field is equals to 60 bytes. The next field is differentiated service code, DSCP. It is 6-bit long. It is used for quality of service, QoS. QoS is very important topic to your CCNA exam. Don't worry about this because we are going to cover it in depth in this course. But what you're supposed to know here is the QoS, quality of service, it is used to prioritize the very sensitive data over the internet. As we know, there is many types of traffic that are sent over the internet. Now, by having the quality of service, it is going to prioritize a very important traffic and sensitive data. They are going to be given the highest priority over the internet. So the other one, they are going to be in the queuing. However, this sensitive data, they're going to be given high priority and they are going to be forwarded due to their priority. Don't worry about this because you're going to cover them in depth in quality of service. Now, the next field is explicit congestion notification, ECN. It is 2 bits long. Now, the summary of this field in the IPv4 header, it is used to send a notification between two nodes end to end. However, for example, maybe there is a network congestion. Maybe let's say the network is very busy. So whenever if the packet is going to be sent from the router is going to drop that packet because the network is very busy. Now, by having this ECN field in the IPv4 header, it is going to send the notification between both two nodes that there is a network congestion now, the packet should not be dropped. And that's all about this field. The next field is the total length. It is 16 bits long, and this field is used to indicate the total length of the packet, which is encapsulated at layer 3 header and layer 4 segment. In this field now is where the actual data that is going to be transmitted in IPv4 is where it's being contained. However, we had a discussion about IHL field in IPv4 header, which stands for Internet Header Length. We said it is a field which is used to indicate the length of IPv4 header. However, it has got the minimum value and the maximum value. So the minimum size of the IHL field is the 20 bytes, and the maximum size of IHL field is 60 bytes. A standard IPv4 header with no option has a fixed size of 20 bytes, which means the IHL field, we say the minimum size it is 20 bytes. So it means it is just the size of IPv4 header. It does not contain any data within it. So keep it on your mind. The size of that field doesn't mean that it contains the total of the data which is going to be transmitted from this IPv4 header. However, for example, when the router receives the packet which is a total length of 60 bytes. Now let's watch here a very simple formula which is going to be used by the router in order to forward that packet. Now for the router to discover and to take the data payload size, it uses this formula. Now the data payload size equals to the total length field which was received by the router, then minus by IHL field which was multiplied by 4 incremental bytes, as once you remember in IHL field. We said IHL field, it is incremental by 4 bytes. So for example, once IHL field, the value is 5 and that which is the minimum value, then we take 5 times 4, we get 20 bytes. And so on, and the maximum value it was 15. Now once we take 15 times 4, we get 60 bytes. Now, let's take here a simple example. Let's say the router has received the packet which has the total length of the 60 bytes. Now from our formula here, so it is going to take the 60 bytes, then minus by IHL field. Now for this scope, it was 20 bytes. Now 60 minus 20 bytes, so equals to 40 bytes. So now the total length of our IPv4 header equals to 40 bytes. The next field is identification field. It is also 16 bits long. Okay, in this field now, what you're supposed to know is, do you remember in the Ethernet video, we used to discuss the minimum and the maximum MTU size in the payload? Now, once you remember the minimum payload size, it was 46 bytes, and the maximum MTU size is 1500 bytes. This it is Ethernet standard for MTU size. Now, for identification field to occur in IPv4 header, so let's take this a simple example. So for example, a router it is use a standard MTU size ambayo ni 1500 bytes. So whenever this router it receive the packet with the total MTU size ambayo ni 400 bytes. Since we said the router inatumia a standard MTU size ambayo ni 1500 bytes. Now for this scope ime receive a packet ambayo ime exceed hiyo maximum MTU size ambayo ni 4000 bytes. Now what is going to be done? For this scope now, this field is going to be happen in IPv4. What does this field is going to do? This field inakwenda kuifanyia fragmentation kwenye hiyo packet ambayo imekuwa received katika hizo bytes. So those bytes ambazo ni 400 bytes zinakuwa fragmented. and those fragments, they are going to be identical. So this router inakwenda fragment hizo 400 bytes maybe into 3 fragments. So maybe fragment 1, fragment number 2, and number 3. And for this router, for this field ili iweze ku happen katika IPv4 header, the packet inatakiwa inatakiwa exceed hii maximum MTU size. So kama MTU size exceed, basi hii field katika identification field inakwenda ku happen katika IPv4, which means it is going to fragment those data so as the router to be able to send that packet to the destination in terms of the fragments. So itakuwa fragment 1, fragment 2, and fragment 3. And those all fragments, they are identical. They are going, so the host anakwenda ku assign maybe an identical number. Those identical number, they are going to be saved at the copy to all fragments that ambazo zimekuwa created, and they are going to be forwarded to the destination. Now, this fragment, they are going to be reassembled by the receiver, not this. So the receiver anakwenda kutumia hizo fragment kuweza kureassemble na kujua hiyo hiyo packet ilikuwa na contain nini au ilikuwa inamaanisha nini. The next field is the flag. It is 3 bits long, and the primary job of this flag is to control and identify the fragmentation as the packet travel across the different networks. Let me explain and use a very simple example as I used in the previous slide. So I said, for example, you are having a router, and your router, it is using a standard MTU size, which is 1500 bytes. Now, your router has received the packet which contains 4000 bytes. 4000 bytes, this has exceeded the standard of MTU, which is 1500 bytes. So what is going to be done? Now your router is going to fragment those packets, which is which was 4000 bytes. It is going to fragment them so as to be forwarded from one network to another network without being fragmented, which means that packet is going to be dropped. The router is not going to be able to fragment those packets. Bit 0. Bit 0, it is a reserved and always are set to 0. So these are reserved for the future use. And the next bit is bit 1. We also can say don't fragment, DF. This it is used to determine if the router is allowed to break these packets apart. So for example, this is the value that is going to help the router to know if that packet should be fragmented or not. So 0 represents this may be fragmented. So if the field is set to bit 1, which is don't fragment, which is DF, and the value is 0, so it means the router may fragment those packets. And if it is set to DF and the value comes to 1, which means the router should not fragment that packet. And the next bit is bit 2, or we can say more fragments, which is MF. This one, it is used during the reassemble. It is used during the assembling to know if more pieces are coming. So for example, if it is set to bit 2, which is MF, and these are the values. So if the router sees this value, which is 0, which means this is the last fragment. There is no any other fragment from there is no any other packet which is fragmented from the source. And if it is set to 1, which means there is more fragments that are coming. Just take this as a simple example. So whenever the router was set to MF and to see this, this value which is 1, so this means it's telling the receiver, hey, just keep waiting and stay cool. There is more fragments which are coming. And whenever it is set to 0 and this it is set to MF, it is saying, hey receiver, you are done. The fragment is done. Now you can use them and reassemble and to know the clear picture of how was the packet it was. Okay, the next field is the fragment offset. It is 13 bits long. It is used to indicate the position of the fragment within the original and unfragment IP packets. So for example, this fragment offset inakwenda kumsaidia a receiver. For example, it has receiving those fragments even if they arrive in different order, yani zime arrive katika order ambayo sio kama ilivyotumwa. So hii fragment offset inaweza kumsaidia kwamba kujua kwamba position ya kila fragment ambayo imekuwa received by huyo receiver, kujua kwamba position ya hii fragment ina contain hapa, inakaa hapa, inakaa hapa. So anatumia them kuweza ku reassemble na kuweza kujua the order of the clear fragment how was sent by the sender. So the next field is the time to leave a field. It is 8 bits long. It is used to prevent the infinite loops over the internet. It was designed to indicate the packet lifetime in seconds, which is known as a hop count. And each time when the packet is alive, the router it increases the TTL value to 1. And the most recommended TTL value it is 64. Now let me give you a good example of a time to leave a field. It is commonly used in a troubleshooting such as a traceroute command. So for example, when you enter in your Windows PC and you open your CMD and write the command, the trace IP address maybe 192.168.10.1. So for the first time, when that packet is going to be sent to the router, by default, the traceroute, the TTL value is set to 1. So what is going to be done? So for the first time, when you send that packet, the router, it's arrived to the router, and as we said, whenever this packet is going to be received by the router it is going to decrease the TTL value to 1. So since the traceroute, the TTL value was set to 1, so once it arrives to the router is going to decrease, it is going to be 0. Now, if it is 0, the router it is supposed to send the ICMP type 11 message to the host that the packet that was sent was time exceeded, so the time was out. So he's supposed to send another and exceed the time. So the host for the second time is going to add the TTL value numbers. So for the first time it was 1, and for the second time it is going to be 2. Then it goes again to the router decrease 1, so 2 minus 1 is remain 1, and it's going to send to another router, and also another router. Once it receives that, it is going to decrease, so it is going to be 0. Again, the message is going to be sent back to the original host, then and so on and so on. So it means the sender it is going to add the TTL value until it reaches the destination network. So this is where this is where commonly used to understand the time to leave field. The next field is header checksum field. It is 16 bits long. So the main purpose of this field is used to detect errors or corruption that might occur during transmission of IPv4 header. And this might be caused due to the power outage or the cable issues and so on. And once you remember very careful, in the previous lecture video of Ethernet header, the last field of Ethernet header it was the frame check sequence. That field is used to detect and checking errors of the frame that might be occurred during the transmission of that frame. So it is going to use the same calculation that was being used by the sender. Then those values are going to be used by the receiver to calculate and matches. If those values are matched, then the frame it is going to be de-encapsulated. If it is not matched, the frame it is going to be dropped. So this is just function the same as that field. However, in this field now, it's quite different, since IPv4 relies on the upper layers to check these errors. So for example, in this field now, it is going to rely on TCP or UDP. Since this TCP and UDP, they have their own method of checksum. Don't worry about this because we are going to cover them in depth about TCP and UDP. They have their own mechanism to check these errors. So IPv4 it is going to rely on those protocols that are going to be used in this field. Okay, the next field is the source and destination IP address. As I said before in the beginning, that I want to spend my time to explain about this, the source and the destination IP address, because I have already made the video about the source and the destination IP address. So if you don't know about the source and the destination IP address, please take your time, go and pursue my previous video of IPv4. I have already explained this in depth. Now, as you can see here, after this field, the next field is the option. This option is rarely used because it relies on the IHL. So for example, the minimum value of IHL it was 5, as I said before. Keep it on mind. The minimum value it is 5 and the maximum value it is 15. Now, If the minimum value was set to 5, this this field option, it is not going to be available. But if IHL it is greater than 5, which means you set to 6, maybe 7 or 8, now the option field is going to be available. I think I will show this in my Wireshark capture to show you how does this field occur in the real world. Okay, for this lecture video, we are going to end here. And please don't forget to support me by subscribe my channel, drop the comment so that let me know if the course is helpful for you. And please don't forget to share this video to your friends. Thank you.